Welcome to Ask Prep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is stoichiometry and mole concept, limiting reagent and empirical. Chemistry is all about understanding how substances interact, combine, and transform. And when it comes to measuring these reactions, stoichiometry plays a key role. It helps us calculate the amounts of reactants and products in a chemical reaction, ensuring that we make the most out of what we have. But one of the most crucial aspects of stoichiometry is understanding the limiting reagent and empirical formula, which are essential for cracking NEET and JEE exams. Every chemical reaction has reactants that combine to form products, but what if one reactant runs out before the other? That's where the concept of the limiting reagent comes in. Imagine you are making sandwiches. You have 10 slices of bread and 6 slices of cheese. If one sandwich needs 2 slices of bread and 1 slice of cheese, you can only make 5 sandwiches. Even though you have extra bread, the cheese is limiting how many sandwiches you can make. Similarly, in a chemical reaction, the reactant that gets completely used up first is called the limiting reagent because it determines the maximum amount of product that can be formed. Now, let's take a look at why the limiting reagent is so important. In real-world applications, from pharmaceutical industries to material synthesis, ensuring that no excess reactant goes to waste saves time, money, and resources. In competitive exams, questions on limiting reagents test your ability to analyze reactions and make quick calculations. To identify the limiting reagent, we compare the mole ratio of the reactants with the coefficients given in a balanced chemical equation. The reactant that produces the least amount of product is the limiting reagent. Once identified, we can calculate the exact amount of products formed using stoichiometric relationships. Moving on, another critical concept in stoichiometry is the empirical formula. The empirical formula represents the simplest whole number ratio of elements in a compound. It gives us insight into the basic composition of a substance, which is fundamental in chemistry. For example, hydrogen peroxide has a molecular formula of H2O2. But its empirical formula is simply Ho because the ratio of hydrogen to oxygen atoms is 1:1. The empirical formula does not always match the molecular formula, but it is essential for determining chemical composition. To determine an empirical formula, we follow a systematic approach. First, we obtain the percentage composition of each element in a compound. Then, we convert these percentages into moles by dividing them by the atomic masses of the respective elements. Next, we simplify the mole ratio to the smallest whole numbers. If necessary, we multiply by a common factor to eliminate fractions and obtain a valid empirical formula. In any given reaction, reactants combine in specific ratios to form products. However, in real-world chemical reactions, one reactant often gets completely consumed before the others. This reactant is known as the limiting reagent. It determines the maximum amount of product that can be formed in the reaction because, once it is used up, the reaction cannot proceed further. Identifying the limiting reagent is essential in industrial and laboratory settings to optimize the use of reactants and minimize waste. To determine the limiting reagent, we compare the mole ratio of the reactants given in the balanced chemical equation with the actual amounts present. The reactant that produces the least amount of product is the limiting reagent. The other reactant, which remains after the reaction has stopped, is called the excess reagent. Understanding the concept of the limiting reagent helps in predicting the efficiency of reactions and in ensuring the correct proportions of reactants are used. Another significant concept in stoichiometry is the empirical formula. The empirical formula of a compound represents the simplest whole number ratio of atoms in that compound. Unlike the molecular formula, which shows the actual number of atoms of each element in a molecule, the empirical formula provides the most reduced form. It is particularly useful when analyzing unknown substances and in determining the composition of compounds. Now, let's move on to the empirical formula. The empirical formula of a compound gives the simplest whole number ratio of atoms present in a molecule. It does not necessarily represent the actual number of atoms in a single molecule but provides the simplest proportion. For instance, hydrogen peroxide has a molecular formula of H2O2, but its empirical formula is O because the ratio of hydrogen to oxygen is simplified to the smallest whole numbers. Similarly, glucose, which has a molecular formula of C6H12O6, has an empirical formula of CH2O. Stoichiometry and the mole concept are indispensable in chemistry, helping scientists and students alike to understand the quantitative aspects of chemical reactions. The ability to calculate limiting reagents ensures efficient resource utilization, while empirical formulas aid in identifying and classifying compounds. Mastering these concepts is crucial for anyone preparing for competitive exams like NEET and JEE, as they form the foundation for solving complex chemical problems and applying theoretical knowledge to practical scenarios. Empirical formulas play a crucial role in identifying unknown compounds, particularly in organic chemistry and material sciences. In exams, solving empirical formula questions requires practice, precision, and an understanding of how elements combine in fixed ratios. In summary, the limiting reagent determines the maximum possible product formation in a reaction, and the empirical formula gives us the simplest ratio of elements in a compound. Mastering these concepts is vital for excelling in chemistry and acing your NEET and JEE exams. Keep practicing, stay curious, and make chemistry your strength. Thank you. We hope this video has helped clarify the complex yet fascinating topic of stoichiometry and mole concept, limiting reagent and empirical. If you found this video useful, don't forget to like, share, and subscribe to Ask Prep for more in-depth lessons and tips on chemistry and other subjects. Keep studying, keep practicing, and good luck with your exams.